Yesterday we created our first class, the person class, and it is woefully incomplete. In fact, there is nothing inside of the class whatsoever. It's just the class being defined. So today we need to flesh out our person class some. Give it a constructor, give it a first name and last name, and the ability to say hello. And let's start with a constructor because, that's kind of the logical place to start because whenever we create a person object, we do so with a constructor. Now we did create a person object yesterday. If we look at program.cs, there's the code. We have created a person object and we have called a person constructor or a constructor for the person class. Now we didn't specify one. So what's going on here? Well, when you don't specify a constructor, one is automatically created for you. It's called the default constructor. And it really doesn't do anything except allow you to create that object. So that's a nice feature, but it doesn't really help us because we want a person to have a first name and a last name whenever we create a new person object. So we do that by writing a constructor. Constructors have the same name as their class, so inside of the code block for the class or the person class, we start our constructor with the word person, and then an open parentheses, and then we specify any parameters that we might want to require someone to pass to our constructor in order to use, like a first name and a last name. But we don't have to specify parameters if we don't want to. We can simply just do an open parentheses and a closing parentheses, and we basically create our own default constructor. But how this differs from the one that's automatically generated for us is now we can put any type of logic inside of this constructor that would execute whenever a person object is created. But in our case, that still isn't very helpful because a person needs at least some information about them, like a first name and a last name. So we do want a set of parameters. And parameters are defined very much like variables, except we're not assigning them data. So we just use the data type and then the name of the parameter, first name, and then we separate parameters with a comma. So we have first name, and now we need last name. So we'll do the same thing for last name. If we had a third parameter, then we would do another comma, and then type whatever our third parameter is. Now we're going to leave this with just the two parameters. Later on, we will add some more parameters, but this is sufficient for now. Now we do have a problem here. And that is because this constructor that we just wrote is not accessible. In most object-oriented programming languages, you have something called accessibility. And it basically gives you the ability to determine what can and cannot be accessed. So our person constructor is not accessible outside of the person class because we haven't defined an accessibility because there is some default values. First, let's look at our class. Anything that is defined inside of a namespace, a class, or any other type of data is automatically defined as internal. We don't have to explicitly say it's internal, it's just automatically done for us. But we can do that if we want to. Internal. So we have internal, class, person. Internal means that this class is available to anything inside of the assembly, or in our case, the My First project. Any code within this project can access this class, because it is internal to this project. If we imported this project into another project, that second project would not be able to access this person class because it is internal to my first project only. But we could make it accessible outside of this project by declaring it as public. So we have the access modifier and then the keyword class, and then the name of the class. And public just, it means what it says. It is now public. So we could use the person class anywhere at any time. And we need to do the same thing for the constructor, because as it is right now, this person constructor is private. Anything that you define inside of a class that you do not specify the accessibility on is automatically private. So that means that only the code within the class person can access this private constructor. That's just how privacy works. So we want this constructor to be accessed outside of the class, so we will give it public as well. So let's go to our program.cs file, and we can see that we have a red squiggly. And if we didn't set public here as the accessibility, we would still have a red squiggly, but it would have a different error here. But the error that we get is that the person class does not contain a constructor that has 0 arguments. And remember that because we didn't have a constructor, one was automatically being created for us, the default constructor. Well, now that we have defined a constructor, we no longer have that default constructor. Now, we could write one if we wanted to, but we don't because we want a first name and last name for our person. So in order to make this code work, we have to pass in some string values for the first name and last name of this person. So let's do John Doe. And we can see now that the red squiggly goes away and Visual Studio locks our code. And in fact, we could run this and it would be fine. Of course, there's really nothing going on because we are creating a person object, but we're not doing anything with it. So now we have some data that's being passed to the constructor, and we need some way to save it within each person object. So we are going to create some what are called fields. These are fields that are for the class, and they're typically only used by the class because fields are typically private. And these are kind of like a class-wide variable. So anything within the class can access these fields because we don't define them inside of a constructor, or we don't define them inside of a method. They are defined only inside of the class. So we have private, string, and then we need first name. And these are a lot like variables, except that we now have the private keyword instead of just string first name. We can also give these a default value if we wanted to. We could do string.empty if we wanted to, but we're just going to declare them. We also need private string last name. And once again, because these are private, they are not accessible outside of the person class. If we try to use these fields in our code, person dot, you can see that first name or last name are not listed there. But if we change this to public, which we do not want to do, we will see that first name is now there. Now, fields, as far as naming conventions are concerned, you are going to hear quite a few opinions. Some people name their fields just like a variable. Some people begin them with an underscore. Some people begin them with an underscore and then a capital letter. It really doesn't matter as long as you are consistent. Because everybody seems to have their own opinion as far as fields are concerned. So I'm just going to name them using camel casing. And I guess true camel casing would be with the capital N for first name and last name. Let's do the same for the parameters. And now inside of the constructor, we need some way to take the data from the parameters and assign them to our fields. Now we could do first name equals first name, but then we get kind of ambiguity here, and we are going to get a green squiggly. In fact, it's probably going to say assignment made to the same variable. Did you mean to assign to something else? In this context, first name is the parameter. It is basically a variable, except we have defined it as a parameter and not as a variable. So we need to specify the first name field and then assign it data from the parameter. And we do that using the this keyword. This refers to this object. So whenever we are working inside of our person class, we can use the this keyword to refer to the object that has been created. So we can do the same thing for last name. And there we go. We now have a constructor getting the first name and last name and assigning those values to the first name and last name private fields. These fields are unique for each person object that we create, so no two person objects are going to have the same values for those fields unless if we actually specify that. So now let's create a method because we want our person objects to say hello to something. We want them to be polite. So defining a method is a lot like a constructor, except for there's two main differences. One, it's not the name of the class because that would be another constructor. And two, it has a return type. Now there are accessibility modifiers that we can use for methods. Public, in this case, is going to allow us to use the say hello method wherever we use a person object. And then we want a return type because we want to see this person saying hello. So it's going to create a string and return that string. So the return type is going to be string. And then the name of our method and the naming for any public member needs to follow the Pascal casing that we talked about. And then we need a name to say hello to. And then anything that we define or put inside of this code block is going to execute whenever we call the say hello method. Now, not every method needs to return a value. Sometimes you are going to write a method that just doesn't return anything, but it of course will do something. And in those cases, you will use the word void. That basically means this is a method, it doesn't return anything. It just does something. But we want to return something, so we are going to say that say hello is returning a string, and then let's return that string. Hello, and then we will concatenate the name together. So let's call this using the console write line person say hello. It's already there for IntelliSense. And then a name. Let's say hello, Jeremy. And then let's run this. And we have a build error somewhere, which is not uncommon. We are missing a closing parenthesis, and this is very common, especially whenever you have multiple method calls within the same statement, which we do with line 18. We are calling writeLine, and then we are calling the say hello method, which is going to return a string to the writeLine method, but we are missing a parenthesis here. And Visual Studio is very good at matching parentheses, matching curly braces, and also these little square brackets together. And we can see that it's matching this closing parenthesis with the opening here, and we need another closing one. And there we go. So whenever we run, we will see, hello, Jeremy. And that's going to wrap up today's lesson. We looked at some very important things today: constructors, private fields, and methods. And tomorrow we are going to continue looking at very important things. We are going to look at properties because we have some information that we might want to make available outside of this class. So I hope you have a wonderful day. I will see you tomorrow.